Okay, this one is for the population, which is for the meal. So X bar is for the sample. Okay, X bar is for the sample. So sampling distribution of sample means now is we are finding the distribution for the mean sample. Alright? Okay, this is the definition. A sampling distribution of sample means is a distribution using the means. Do you see the keyword here? Means. Compute from all possible random sample, okay, random sample of a same size taken from a population. So you know already sample must be taken from the population. Am I right? Okay. So how to find the sampling distribution for the sample mean? We are using the method of the central limit theorem. Okay? We are using the central limit theorem to find the sampling distribution for the sample mean. Okay, now look at this. Okay, this is a mean for the sample mean. It will be still the same using the same mean. Okay, but when it comes to standard deviation, right? Standard deviation, you need to divide by something. The special is here. We need to divide by n. Alright? Okay, this is the one you see last week, right? Do you still remember for this one? Normal distribution. Still remember or not? We set in x and with what is the value we need? Mean and standard deviation, right? Okay, now for today, for the sampling distribution of sample mean, the formula will be slightly different at the part of the standard deviation here. Do you notice that? Others still the same. But when you come to the denominator for the standard deviation, you need to use the standard deviation divided by the square root of n. Okay? For the application, we can see the example. Okay, this example actually is get from your slide. Alright? So again, for this case, we are using the Z table. Okay, we're using the Z table. Now, a survey reports that the children between the age of 2 and 5 watch an average of 25 hours. This is what? The first information given, right? Average of 25 hours. Alright? Of television per week. Assume the variable is normally distributed and the standard deviation is 3 hours. Standard deviation is 3 hours. Alright? If 20 children between the age of 2 and 5 are selected random, find the probability that the mean, okay, this one 20 actually is n. So find the probability that the mean of numbers greater than 26.3 hours. So it means that we are finding what? P more than 26.3. Alright? But based on the information given, what do we have? We have the mu x bar, right? It's what? 25. Our standard deviation is 3, but we need to divide by n. Am I right? For the new, okay, this one is the sigma for x bar. It's referred to the sample mean. Okay? Clear? Clear? So now we will come to the calculation. Okay? Come to the calculation. So the calculation is equal to PC more than, as usual, we need to minus it, right? Minus the mean given is 25. Divide by the sigma over square root of n. Right? So again, you always remember that once you apply the formula, you must be changed to Z. Remember not? Once we apply the formula from the X, we have to change to Z, right? For the last week one. So today, the mean, we will change to Z as well. Okay? So can you try to get the value for me? Press your calculator. Z more than what? So you have to press correctly and carefully. 1.9 something, 1.938. Is it? Yes, right? Okay, now how to refer to the table? 1.9. Is it here? 1.9. 3 is where is it? 3 is here, right? And 8 is here. So what is the value right now? So 0.0268 minus 5, right? So what do you get? 0.0263, right? Is it correct or not? Okay? So now, do you see the explanation at the bottom here? Okay? So the answer will be slightly different. Okay, sometimes with the small decimal places is okay. So if you want to convert it to the percentage, it will be equal to 2.63%. You just need to what? Times 100%. Right? Okay? So now, the explanation will be, hence, the probability of obtaining a sample mean more than 26.3 hours is 0.0262, or you want to convert the percentage with 0.262. Okay? Because now we get is 3, so you can say that 263 and then 2.63%. Okay, this is the explanation. And we notice that there's a keyword here, sample mean. That's why our questions here, we have the X bar. Okay, our question, we have the X bar. See here? Do you notice that? Okay, when it comes to the question, even in asking you to find the sampling distribution for the sample mean. Okay, for the sample mean. So everything, okay, will be the same except the denominator for the standard deviation. We need to divide by the square of n here. Do you see that just now? This one? Last week we learned just divide by the sigma, right? But now it's sigma divided by square root of n. Okay? This is a difference from the last week we learned. Alright? So far so good? Okay, are you ready? So this is the next example given from your slides as well. Okay, now we have to find 90 to 100. Am I right? It's between. Okay, H is between 90 to 100. Okay, so this one is 8 years or 96 months, but we are using this one because of the standard deviation also given 16 months. So we're still using the months, refer to months as well. Okay, make it standardized. So our mu is what now? 96. How about our sigma for the mean sample? It will be 16 divided by square root of 36. Am I right? Because we have the n is a 36 halves. So you need to set it. Okay? So now we are finding P between is you have the equal sign, mean, right? You see the word here is mean, so equal, okay, 100. So again, we need to convert it to z. So we are applying the formula with 90 minus 96 divided by 16 divided by square of 36. Okay, so now it's less than. Okay, if you want to put equal also can, because for the continuous is like not matter, doesn't matter for the equal sign. Change to z and then 100 minus 96 divided by 16 square root of 36. Okay, so far so good? Is that too fast? Okay, what do you get this? First must be negative, obviously. Okay, 2.25. Yeah, 2.25. Okay, Z. Yeah, negative. And the last, next. 1.5. Exactly 1.5. Okay, now, for this case, just now I didn't draw the normal diagram, right? Okay, we can just draw it now. So from here it's like negative 2.25 at the left hand side, and 1.5 will be at the right hand side. The shaded region is in the between, right? So what is the formula we have to use? Yes, good. 1 minus. Okay, 1 minus the part that we don't want, that in pink color, right? Okay, so this one will be equal to 1 minus P Z more than 2.25, right? Everything will be changed to positive. Okay, because the graph given, the table given will be at the right hand side, right? Okay, I told you last week. And minus the 1 P Z more than 1.5. Is it? Okay, so we refer the table for the 2.25. 2.25. Okay, 2.25 is here. Okay, 2.25. So will be 1 minus 0.0. Oh, so small. What? 122. Okay, thank you. Because too small already. And next minus 1.5. 0.0668, right? Okay, now we can copy to here. Actually, it's based on your understanding. So it's PZ more than 2.25 and minus PZ more than 1.5. So we equal to 1 minus 0.0122 minus 0.0668. So what do you get? 0.921 or 911? 921. Okay, boy, check again. It should be 921. Okay, so if you want to convert to the percentage, you'll be getting what? 92.1%, right? Okay, so this is an explanation. Hence, the probability of obtaining a sample mean of the edge between the 90 and 100 will be this one. Okay, so this is the explanation, and you can see the keyword is a sample mean. A sample mean. Okay, understand? Okay, this one is asking when to apply the center limit theorem. Okay, do you see the keyword highlighter there? Okay, and I also keep emphasize it. Like the second one, the formula, see sample mean, right? Do you see that? Okay, so this is a difference between the formula. So the first one is a normal distribution. Why we need to, okay, when we have to use that, when the data is an individually data value. Last week we learned I just give you the x, right, and give you a certain value, and you need to find the area, okay, shaded under the line, okay, under the graph. So this is the z, but now still the same. I'm using the z, but the question given already in the sample mean. Sample mean. This is the difference on it. Okay, and when come to the question is asking you the sample mean, so what you have to use, the formula, the difference, again, denominator will be different. Alright? Understand or not? Yes, huh? So last week we learned that, okay, when it comes to the number of the sample is very big and also our p is very small, we will change it by using from the binomial to the Poisson, right? And I also show you the calculation, what's the difference. Although at the end you get the same answer, but the calculation, Poisson will become to the simple, right? Remember or not? Last week I showed you the calculation. So today we have to learn from the binomial, convert it to the normal. So binomial actually is under what? Discrete count. Okay? Normal distribution is under continuous. Okay, so see the one, the green one, the highlighted one, this one. Okay, this one is we learned last week. Remember or not? When n is very large and our p is very small, so the np is like less than equal to 20, we will be using Poisson distribution, right? Okay, remember or not? But now today will be the case like when n is very large, okay, and we will check with the p as well, but at the same time we also have to check with the nq. So nq must be more than or equal to 5. The difference is the one we check is only np, okay, for the Poisson we only check np. But now this one is not only checking the np, at the same time we also have to check nq. Okay, so if fulfill this case is both of them, the cases is bigger and equal to 5, we're using normal distribution. Okay, try to understand the theory first, okay, but later when you come to application, you can see the difference on it. Alright? So for this one, okay, binomial actually is a discrete, okay, and normal will change it to continuous. So you see it as adding and subtracting the 0.5. So when from here to here, you have to know that we have a slight difference with the additional, okay, or subtracting for 0.5. So we call it as correction for continuity. We call it as correction for continuity. Okay, so the best way to understand this, okay, my method is I will draw this. Okay, let's say this is the one, the first one. S is equal to A. So I will draw the A here. Equal means that exactly located at A, right? So you have to minus 0.5 is again difference for minus 0.5 and also 0.5 here. So this is minus and this is plus. That's why you can see you're getting this and this. Okay? This is a continuous case. Okay, never mind, slowly you will understand that. Okay, let's say now it's A is more than and equal to A. So this one will be equivalent and going here, right? So we will going back slightly with negative 0.5. So that's why you're coming here. Okay? Slowly, you see the difference on it. Okay, now it's bigger only. When there's bigger only is A, okay, I put it in the circle and I go to the right hand side, right? Bigger is go to the right hand side, right? Okay, the A, exactly the A is not included. So you have to do going backward a bit with plus 0.5. So you can see this is plus. Okay? Then this one smaller, right? And equal. Equal means that A will be equivalent, right? So we need to including the A. So the correction for the continuity, it will be plus 0.5 here because this one here will be included. So we need to slightly go back a bit with the plus 0.5. Okay, this one is smaller than A. Okay, I saw some of the students' face already. What is this? Okay, A is not included. Then we will what? Going to the left hand side with 0.5. So we use minus. Okay, not really. Okay, never mind. We see the example. Okay, this one will come back later. We'll see the example here. Okay, now. Let's say for this case, a magazine reported that 6% of Malaysian drivers read the newspaper while driving. So obviously now our P is 0.006. Is it? Sorry. Is 0.06, right? Okay, so automatic for our Q is using 1 minus P, right? So 1 minus P is 1 minus 0.06, right? We get 0.94. Okay? And based on the information given, we have also the 300 drivers. So our N is 300. Okay, so just now we need two formulas, NP and NQ. So we need to check this one, we have to use normal or not. Okay, so NP will be N times P will be equal to 300 times 0.06, and you will get what? 18. So our 18, is more than or equal to 5? Yes, right? Yes. Fulfill the first case. Now, we come for the second one is NQ. So it's 300 multiplied with 0.94. What do we get? 282. Your friend getting 282. Same as yours? Okay, again, is it bigger than equal to 5? Okay, now these two cases is fulfilling. So we have to convert it to using the normal distribution. Okay, so normal distribution, okay, and based on the question it's asking you to find exactly 25. Am I right? 25. So actually we are finding what? P, yes, x equal to 25. Okay, when x equal to 25, we have to using this method, right? X equal to 25. So from the binomial, we have to convert it to the normal distribution. Normal distribution. So our normal distribution, we're using this formula with a minus and plus. Okay, now, if you look at the line graph, right? This is 25 exactly. So we need this one. We need this one. So you can imagine that, the best way to imagine that, because we already color it, right? Exactly. This color already exit here and exit here. I think this one will be the way will be easier to remember. We make it a black, okay, the black dot. Okay, we color it inside as well. So this one will be included. So when you color it, is it this part will be have the minus 0.5 included, this one plus 0.5 included because you color for the big circle one. Okay, you already exit the place. So this part will be included as well. Okay, try to understand in this way. So it will be P 25 minus 0.5 less than x and less than 25 plus 0.5. So which means that this part we included, this part we also included. Am I right? Is it easier to understand in this way? Yes, okay, good. So now, we need to change it to the z value right now. So before we change it to z, we simplify it first, make it nicely. This is 0.5, so it's 25.5 here. Now we change it to z. So z is what? Our formula is what? Z is equal to x minus mu. This is not sample mean, right? Just give you the x value. So we divide by the sigma. Okay, so sigma, we need the formula. Okay, so mean actually we get in here already. This is mean, right? The formula is mean, right? To get mean for the binomial distribution is equal to NP. Am I right? Okay, so NP is the mean, so our mean right now is 18. So our standard deviation is NPQ, right? So you need to calculate it. Our P is 0.606 and multiply with 0.94. So you will get what? 4 point something. For the one? Standard deviation, NPQ. Okay, sorry, this is a variance, right? Because after that we need to square it. So this is a square root. We need to put in the square root. Not enough space. This one should be at 0.94 should be at here. Because not enough space. Okay, square root. We need square root. I forgot already. So what do you get? 1, 1. 113. Is it every one of you get the same? Okay, good. So now substitute to the equation. Minus the mean is 18. Divide by 4.113. Now becomes z already. So 25.5 minus 18 divided by 4.113. So what do you get? Equal to P, is it 1.58 here? Less than Z, less than 1.823. Same as yours. So when you check the region, have to check it correctly. So both will be at the right hand side, am I right? This is 1.58, this is 1.823, and our region is this one, within. Okay, this part. So how to get the part that we want? The shelter region here. How can we get that? We have to use the bigger than 1.58 overall minus the one that we want, which is bigger than 1.823. Am I right? Use the table. The table will be always at the right hand side, what? The area. Okay? So it will be equal to PZ more than 1.58 minus PZ more than 1.823. So what do you get? Refer the table, 1.58, what do you get? Okay, 0.0571 minus. The next one is 0.0342. So at the end, what do you get? Is it 0.0229? Same or not? We go back to this. Okay, just now for the first example that we did, okay, we have to check the NP and also NQ, right? Do you see the one, the steps, the flow? We check the NP, N times the P, is it bigger and equal to 5? We check the first one. After that, we have to check with the NQ. So when the NQ is also bigger and equal to 5, then we have to convert it to the normal distribution. And this is the one that we learned last week. Okay, this is a formula for the one, for the binomial distribution. The mean is equal to M times P, or because it's a mu, right? Or expected value, it's the same thing for the mean. So standard deviation will be the square root of MPQ. Okay? This one, for the part of the binomial, just recall actually. This is the second example from your slide. Okay? So now it's given if the baseball player's batting average 0.320 means that it's 32%. Find the probability that the player will get at most 26 hits in 100 times at bat. So what is the information given here right now? Is it P? The events of the interest is 0.32. Right? Yes. Okay, our Q will be what? 1 minus 0.32. What do you get? .68, right? Okay, so far so good for the P and Q? Yes. What is the information given some more? N. What is our N? 100 times. Right? Okay, why we don't want to use the binomial right now? Do you see that given N is equal to 100? And what we have finding now? P and most. And most 26 means that what? X is less than or equal to 26, am I right? Okay, let's say if you are using binomial. If there's a binomial, x is less than equal to 26, means that you have to start to calculate from x equal to 0 plus x equal to 1 plus x equal to 2 plus until px equal to 26. Is it will be tired you? And count you? Okay, so that's why we have to convert it to the Poisson or normal. You get what I mean or not? Okay, so now, okay, we have to check whether we have to use that or not, because no space for me for this part already. I will write at another side. Huh? So now we check. Our MP is 100 times what? Our P is 0.32, am I right? So this one is 32, is it? Yes, right? Okay, is it this one is bigger and equal to 5? Is it bigger than that? Yes, right? Yes, so we fulfill the first case. Or at the same time, we also get the mean already, okay, which is the expected number, right? Okay, next, we need to check NQ. Our NQ is 100 times what? 0.68. So what do you get? 68, right? So is it also bigger and equal to 5? Yes. So remember, the method you learn this to replace that because of want to save your work and save your energy. Okay? So now, what you have to do for next? Okay, we need to convert it to the z right now. Okay, but before convert to z, we need the x value. Okay, from the discrete, okay, for binomial change to continuous. So now, if you draw the line, it's less than 26 here, right? So is it this one is a big dot if there's an equivalent? So you're drawing here, right? Less than equal. Is it this one will be included? So do you notice that when you draw the black dot, is it including this part as well? So we need to plus 0.5, am I right? So we'll be referred to this case. Same as this. So I would prefer you to understand it rather than you just memorize the grid table. Get what I mean? Okay, so now what you will be getting? So x will be less than 26 plus 0.5. Clear? So it will be equal to px less than 26.5. Okay, we change to z less than 26.5 minus 32, right? Our mean divided by our standard deviation. What do we have standard deviation? So you need to addition calculation here. So standard deviation is square root of MPQ. So will be 100 times 0.32 times 0.68. Okay, what do you get? So 4.665, okay, and you're getting what? PZ less than negative something? Is it negative something? We try to draw the shaded region. We check which part will be shaded. So less than 1 point something will be at the left hand side. Left hand side. Okay, so it will be equivalent to what? Positive, right? 1.179, right? Okay, so now you can step the equation in this way. Okay, means that step by step, no? So what is the answer you get? 0.1192. Is it the same? Okay, if you want to convert it to the percentage, we want 1.92%. Okay, clear?